All right, on this problem, I want to talk a little bit about kind of estimating and figuring out what we're doing. It's asking us to find at the top here the maximum z-score that a data point can have in order to remain in the bottom 30% of any set of data. So we're assuming that we're in a normal curve since we're talking about z-scores, and we already know that based on the empirical rules, 68% of the data is between -1 and +1 standard deviation. So given that we know that 68% are in here, that means there's 34% here and 34% here. It's asking us where we need to be to make sure that we are within the bottom 30% of the data, or more specifically, what's the maximum z-score it can have to stay in the bottom 30%. So we kind of, hopefully it makes sense to you that from here over is 50% of the data, because the mean, the median, and the mode, that's the middle, so half of the stuff is smaller and half of the stuff is bigger. So we know already, since we want the lower 30% of this curve, that since this is 30% or 50% all the way over here, this is 34%, then we know that 50 minus 34 is 16%. So there's only 16% of the data over here, which means that to get to stay within the lower 30%, we're going to have to be somewhere around here, but we're not really sure. It's not a specific place. So the help thing on Hawks tells you one way to do it, and I kind of want to express another way to do it. I'm going to introduce the normal curve tables that are linked on your Hawks course, and I've also provided copies of them. I suggest you print them because it's so much easier. So we're looking for the lower 30%. What do we need to do to stay in the lower 30%? And we're going to look at this normal curve table that tells you the percentage below a certain z-score. So we want to be below 30% for this problem. So if we look at it, if we're at negative 3.49, like really way far over here, only a very, very small amount of data is there. And if we were here at z-score 0, which is way down at the bottom, I think I might need to zoom out a little bit. Way down at the bottom of the table, z-score 0 would be 50% of the data, like I was just saying on the curve. Z-score of 0 right here, 50% of the data is below there. So we know we don't want 50%. They say we want to know how we can make sure we're below 30%. So with this, you kind of just like look around, and if you're dyslexic at all, a ruler helps, printing it out helps. So we're going to move up 50%, and it's going to get smaller as our z-scores go from 0 to 1 to more. And we know it has to be between 0 and -1 to be the 30%. So we're going to go up. We're at 49%, 45%, 41%, 37%, 34%, 30.5%. Okay, so I was just going up. Right here, we've got these two data points that I'm going to zoom in on. Hopefully that will make them clearer. They want us to stay below the 30%. The maximum z-score to guarantee that we are in the bottom 30%. So this would be 30.15%. So we've got to go with this one. That's the closest we're going to get with this. Is that'll put us in the bottom 29.81%. But to figure out what that z-score is, this table goes backwards, or we're using the table backwards. We've got this value right here that we're looking at. The 29% is what we're going to go with. So that's here, and that comes over to the -0.5. Hopefully you see the -0.5 there. And that's the tenths of a percent place. Then we've got to go up on this and look at 0.5 what. So when we go up on this, come up here, we've got negative 0.53. So that's the hundredths place. So we've got negative 0.53, which means it kind of makes sense from the drawing we just had. And that's about where I put it. Here's our z-score of 0. Here's our z-score of negative 1. And I kind of drew it a little bit to the left. I think that was just luck, though. So this is the z-score of negative 0.53 gives us, what was it, 29 point something percent of data falls below there. And this problem, they're looking backwards to find the z-score of negative 0.53. So I'd want to address something else with that. Let me go ahead and put this in to convince you all that this is right. Let's see. Negative, I can't find the negative, 0.53. And then it says yes, yay. And then what I'm going to do is I'm going to find a similar problem. So hold on. Here we have a similar problem. And in this case, rather than saying the bottom 30%, it's saying the top 30%. But something you need to know about normal curves is that they're symmetric. So if we folded around, wow, I put it almost exactly in the middle of the paper too. That's kind of odd. If we folded exactly around that 0, z-score of 0, and we needed to know what was in the top 30%, we'd be in the same place over here. Okay, so rather than a z-score of negative 5.3, it's going to be a z-score of positive 0.53. I think I said that wrong earlier. Positive 0.53. And let's go ahead and look at the table for that now to see if you see how that correlates. This is going to take a little bit more thinking. It's asking us to make sure we're in the top 30%. Okay, so if we're in the top 30%, then we don't want to be in the bottom 70%. So we have to be above 70%. So if we look here, 69.85 is almost there. 70.19, this is the one that just barely bumps you into not being or being not in the 70th percentile or above there. So that would be up here, meaning that's the first place on here that we'd be into the top 30 percentile. But for a lot of people, it's easier to just look at the symmetry and to do it the other way. I just wanted to show you that it is the same. Here we've got our 0.5. We go up, and it's 0.53 that we would get for this one as well. But this time it's positive. So let's go ahead and type that in. And hopefully this will help you all see how to use that chart. So this time it's positive 0.53. It says yay. Hopefully you're saying yay. Several people emailed me and asked me questions similar to this, and I just really wanted to kind of introduce the table that I've put on the discussion board, and the book has it. Let's see if I can get back to where the book has it really quickly. Save and exit. The book has it in the main place. It's right here, stat tables. So that's where the online tools are. It has a ton of stat tables, way more than we need. And I really feel like if you're going to print anything, print this out. I've put it on the discussion board. I'll probably put it in other places as well. Just let me know. I would definitely print this out. It's so much easier to look at it by hand. Hope you all are doing well. Take care. Thanks.